Hey you guys, today we want to find equivalent fractions. So looking at our only goal here is we want to find equivalent fractions that are larger and smaller than the original fraction that you're given. So quick review. The only thing I really like to review is the top of a fraction is called the numerator and the bottom is called the denominator. Alright, let's get into our lesson here. Equivalent fractions. You want to write this down now. Equivalent fractions are fractions that mean the exact same amount, same space, but they're different fractions. So let's look at that. 1/2 and 2/4 are different fractions, but they equal half of a circle. Just 2/4 has a few more cuts in it, but this shaded part is still the same. So again, equivalent fractions are different fractions that represent the same amount. All right, another thing we need to look at is the identity property. If I want to find equal fractions, you got to remember that if I take a number times 1, I'll get that same number back. Actually, any number, if you times it by 1, you'll get the same number back. For example, if you take 5 and I take 5 times 1, what do you get? Well, I get 5 back. It doesn't change. That's the identity. 5 keeps its identity. That's why we call it the identity property. So we're going to use that concept here when we find equal fractions. So here we go. Here's 11/11. I want to break it. I'm going to make this little 1, little red 1 here, to represent 11 out of 11. So 5 out of 5, same thing. 7 out of 7, it represents the whole thing, which equals 1. Or 3 out of 3. Any number over itself represents a whole, which is equal to 1, which is the identity. So we're going to put those two concepts together here. So now I want to take 2/3 and I want to find an equal fraction of 22/3. Well, how do I get that? Well, I'm going to multiply 2/3 times 1, but the 1 is really 11/11 like we learned on the last slide. So I'm going to multiply across, take 2 times 11 and 3 times 11, which will give me 22/33. And that should be equal, because any number times 1 equals the same number. Well, these are equivalent fractions. They're the same space, same amount, just different fractions. So let's go to the calculator and look here. I'm going to take 2 divided by 3. And you come up with 6 repeating. And let's take 22 divided by 33. It should be the same, and it is, because I'm multiplying by 1, which doesn't change it. So let's go on the next one. I want to take 2/3 times 5/5. Now when you multiply fractions, remember to multiply the top and multiply the bottom. So 2 times 5, 10. 3 times 5, 15. So again, 2/3, 10/15, same equivalent fractions. They look different, but they represent the same amount. Same here. I have 2/3 times 7/7. You can see it's 14/21. And that's equivalent to 2/3. And the same, 2/3 times 3/3. So 2 times 3, 6. 3 times 3, 9. 9, 6/9, 2/3. Same thing. Look, they're all equivalent. All these fractions are equivalent. They all represent the same space, same amount of space. But we can write them in different numbers. Just means I put more cuts in that circle. All right, let's try it on our own now. if I take 3/8 and I want to find the equivalent fraction to 3/8, so I'm going to start out, I'm going to use 3/3. Doesn't matter, you can choose any one you want. So now 3 times 3, multiply across, I get 9. 8 times 3, 24. And again now, 3/8 and 9/24 are equivalent. You can use whatever you want. 3/3, 5/5, 3 times 5, 15, 8 times 5, 40. So now I have another set of equivalent fractions. How about, here's an easy one, 2. 2/2. That's equal to 1. So 3/8, or 3 times 2, 6. 8 times 2, 16. What if I do 100? 100/100. Well, this is still 1, and any number times 1 will keep its identity. So 3 times 100, 300. And 8 times 100 is 800. Just, it's the same, just a lot more cuts. All right, what if I give you the bottom part? And I want equivalent fractions, what would the top be? Well, what we have to first look at is say, okay, what did I multiply by to get from 9 to 72? Well, that's easy. I multiplied by 8. Well, again, it's got to be the identity, so I got to keep the top the same. So I have to multiply the top by 8 as well. So 7 times 8, 56. Those are equivalent. And then what if I want to get 56 and I want to go back down? Well, what did I do? Well, or you can look at what did I multiply by. Either way, I times 8 times 7, and I got 56. Well, if I multiply 7 here, I have to multiply 7 on the top. So what times 7 gives me 21? Well, 21 divided by 7, 3. And again, 4 times 5. All right, you get the pattern. And then I multiply by 5. I'm going to get 35. One more. 2 times what is 18? Well, 2 times 9 is 18. So if I multiply 9 on the top, I multiply 9 on the bottom. So what times 9 gives me 45? Well, that's easy. 2/5, yep. So either you find the denominator or the numerator of equivalent fractions. All right, keep coming. Just keep going here. Are these fractions equivalent? They may just ask us, are these equal? Are they equivalent? Well, just use what we learned. What's 7 times 4 is 28. So the question here is, if I multiply 4 on the bottom and I multiply 4 on the top, is 4 times 4 12? No. So are these equivalent? No, because that would have to be 16. Look at the next one. 10 times 3. Yeah, you're already seeing it. Times 3. Is this equivalent? No, this would have to be a 9. So these are not equivalent. All right. How about here? 8 times, or 6 times 8. Yep. 5 times 8. If we multiply on the bottom, multiply on the top, and that's works out. Those are equivalent because these work out. Last one, 9 times 6. If I multiply 6, is it 6 times 6, 36? Yes. Those are equivalent. So you can check to see if you have equivalent fractions. All right. What if I have another question? Is there a number that I can find that falls between 1/3 and 2/3? Is there a number that falls between 1/3 and 2/3? Well, you're going to say no. There's no number because that's 1 and that's 2. But there is. If I want to find equivalent fractions, if you see, I multiply the top and the bottom by 8 for both of them. So I bump 1 times 8 8, and 3 times 8 is 24. So these are equivalent right here, 8 and 1/3 and 8/24. And same for 2/3. Now, I just made them equivalent fractions, but I have more cuts. And now I can see, yes, there are numbers that fall between 8/24 and 16/24. So what are they? What are some of the numbers that are in between these? Are in between 1/3 and 2/3? Well, there's a lot. But how about 10/24? And 11/24? Anything falls between 8 and 16/24 will work. All right, a couple more. 12/16. Now, can we make equivalent fractions that are smaller? Can I go back down? Yeah, we're going to call this simplifying. So you want to do the same. You want to look to say, okay, is there a number that goes into both 12 and 16? Yeah, that's easy. They're both even. So I'm going to divide. Instead of multiplying, I can divide by the same number. My identity is 2/2 here. So 12 divided by 2, 6. 16 divided by 2, 8. And yes, look, I can take out another 2. I just keep on going till I get it all the way down to its simplest form. So I divide top and bottom by 2, and I get 3/4. These are equivalent. Let's go down to 20/80. Well, if I look, they both end in 0. Well, that's 10. So I'm going to take the 10 out of there. So we want to quickly take out a 10 out of top and bottom, dividing. And so what does that give us? 20 divided by 10, 2. 80 divided by 10, 8. But don't stop. Look, they're both even again, just like up above. So let's take out that 2. And now I get 1/4. So 20/80 is really 1/4 in simplest form. Okay, a couple more. 24/36. What if I get the biggest one first? Could I do it too? Yeah. But if you know your facts, you can save some time and say, what goes into 24 and 36? Oh, I know 12 does. Could you do it too? Sure, you can. But I'm going to divide top and bottom by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. There's my simplest form. There's a shortcut I want to show you for 300/600. If you look, they both have 2 zeros. So that means I can take out 100. But the shortcut is this, real fast. I can just cross out the 2 zeros. I just divided out 100 by crossing out 2 zeros. So what do I have left? Well, I got 3/6. And some of you are going to say, well, that's easy. I see that. That's 3 is half of 6. But don't forget 3. A lot of kids forget to. They remember 2. But you got to remember to look at 3. 3 goes into both of these. If I take out 3/3, I'm going to get 1/2. It's really a half. All right, one more. Let's look at some fractions with looking at a denominator of 10 and 100. In our next videos, we're going to be wanting to be able to find an equivalent fraction where the denominator is either 10 or 100. So if I have 3/4 and I want to look, can I get 4 to 10? No, 4 doesn't go nicely into 10, but can I get 4 into 100? So I'm going to look at just those two and say, can I get them there? Well, if I look, 4 times 4/4, 4 times 25. So if I multiply 25 on the bottom, multiply 25 on the top, I'm going to get 75. You're going to be doing this here in another videos in the upcoming days here. So 75/100, oops, 75/100 is the same equivalent to 3/4. How about 2/5? Well, ask the question, does 5 go into 10? Yeah, quick. Yeah, times 2. So multiply 2 on the bottom, multiply 2 on the top, you get 4/10. How about 24 over 60? Well, does 60 go to 10? Yeah, just like the next one. Sometimes I can divide instead of multiplying. So if I divide by 6 and divide by 6, I can bring it down to 10, and 24 divided by 6 is 4/10. That's as far as we want to go. We want to just get it to 100 or get it to 10. Now, does 8 go to 10? No. Does 8 go 100? No. So sometimes this doesn't work for all fractions. All right. Let's wrap it up here. I can make equivalent fractions that are bigger by doing what? By multiplying top and bottom by the same number. Make sure you have this written down now. I can find equivalent fractions by multiplying top and bottom by the same number. And I can make equivalent fractions by dividing. I can knock it down by dividing top and bottom by the same number. This is called reducing or simplifying fractions. All right, thanks, and we'll catch you later.